So it's 7. Let's start. Good evening. Welcome, everyone. Welcome to the second masterclass organized by Jaipur Surgical Tutorial. Those who were not there yesterday, Jaipur Surgical Tutorial is an online education portal which we started at the Mahatma Gandhi Medical College Hospital in Jaipur, in the state of Rajasthan in India about 2.5 years ago. And my colleague, Dr. Anand Nagar, has been coordinating all the programming, schedule, and activities of Jaipur Surgical Tutorial. Normally, we do a 1-hour session on Saturday morning, 9 to 10. So those of you who want to join Jaipur Surgical Tutorial, in between, I'll be putting Dr. Anand's contact details. Please send him a WhatsApp message. And then we thought that we might as well start a once-in-a-month masterclass. So last month, we started this activity. We did a first masterclass on living donor liver transplant. These are 2-day activities, last Thursday and Friday of a month, 7 to 9 p.m. on 2 days, so 4 hours for each topic. All the JST sessions which have been held so far, as well as the videos of the last masterclass and yesterday's session, they are available on the YouTube channel of Jaipur Surgical Tutorial. I will put that link also in the chat in between. So those who have missed, they can watch it for free on the YouTube channel. And today is the second day of this masterclass on safe cholecystectomy. So we'll continue with the program. And to chair the first presentation, which is by Dr. Kamaljeet Singh, who's a senior consultant GI surgeon in Jalandhar, who's again an alumnus of SCPGI like me and Dr. Sikora and Dr. Ajay. And to chair this session, we have Dr. Shalu Gupta. She is a professor of surgery at the SMS Medical College in Jaipur, and she is also the president of the ASI chapter of Rajasthan, and she's an executive member of the ASI. Welcome, Dr. Shalu. Please start the session.
Thank you, sir. Good evening to all. We are starting today's program with a very important topic. Without port, without instrument, and without energy device, we can't do any surgery. So our today topic is how to handle port, instrument, and energy device by Dr. Kamaljeet Singh. Over to Kamaljeet, sir.
I'm sharing my screen.
Yeah.
Yes, sir.
Yes, good. Please start.
So good evening, ladies and gentlemen, and my teachers, peers, friends, juniors, and colleagues. And thank you, Dr. Shalu, for the introduction. Dr. Kapoor, thank you so much for this forum. And Dr. Sikora, it's so loud and clear that we've learned what we've learned from you. We are sharing with other people. And I think that is how surgery grows. And without any further ado, I'll just start off. The main dictum of surgery is that you must know your arsenal well. Otherwise, you're going to be in deep trouble. And that is somewhat my edict for today, that ports, instruments, and energy devices. And good evening from Jalandhar. So this is a patient. This site is quite familiar to us GI surgeons. And this, if you see here, there's a large duodenal perforation. It's almost nearly the bend of the one. And this could not have been anything except a mishap from the cautery. I'll come again, revisit what we need to call cautery. And this is, whether it's a technical complication or a technological complication, is as good your guess as mine. So why are we supposed to be so serious about our arsenal? Why we are so disturbed about it, and why we are so concentrating on this seemingly accessory focus? Now you see, there are 3 big cases with large kind of denominations of the money that has been inflicted upon the surgeon. This is $250,000. This is $2.8 million. This is $10 million. And all these 3 cases are related to a surgical mishap during laparoscopic surgery. And most commonly, the causes in all these 3 cases were energy device related. So knowing how to manage complications is fine, but we are sitting here to avoid them. That's how we avoid our heartache and also the agony to the patient. It's essential to have good tools, but the tools should be also used in the right way. That's our primary thing. So if we see the waves, we're going to have a brief introduction of electrical sciences as should be known by the surgeon. This is the complete spectrum of energy, and our cautery somewhere lies here. What is very important to know is that these are the transmission waves where the energy jumps from one place to another. So you have to be very clear that even in our cautery, the energy can jump from one place to another without any contact. How it will happen, I'll come to very soon. Whenever we buy a weapon, we only see its exterior advantages. But if you see, each weapon has a very dangerous aspect. This is to surgery as well. And if this dangerous aspect is not known, then we can get into deep, serious trouble during surgery. Now, how do I apply this scenario, the weapon scenario, to my arsenal? If you see the image on the left side, is just an innocuous collection of our instruments. They are harmless when they are kept here, like this, independently. When they are articulated like this, presume this gray thing to be the patient. When they are articulated and assembled like this, when this is going to the cautery unit and this is also going to the cautery unit, then this becomes a very, very dangerous weapon. This becomes an electrical capacitor. I will tell you how. This becomes an electrical capacitor, means that it has, in this part, can hold a lot of energy without your knowledge. And that's where we land into trouble. So a lot of people say there's judicious use of cautery. I at times wonder whether there can ever be a judicious use of cautery. Because why? Because you see, the current not only travels through physical contact, but it jumps to, this is very important to know that the current is not going in a straight line. It jumps from one place to another, and even from sealed parts of active instruments to other organs, which are usually not necessarily placed to the area of dissection, but placed much far away from the active electrode. So in this background, can the cautery usage be ever judicious? I would rather say cautery is a dangerous weapon, and it can only be used injudiciously, howsoever smart or howsoever careful. How? Let's come to that. So this soldier is out in the battlefield, and in a battle, we need three things: skill set, strategy, and enemy. We need to know what the enemy's skill set is. Now, this is none of my business today. I am going to be focusing upon the weapons. This is the small gamut which I'm going to, adhere to. And this includes ports, instruments, and energy devices, right? So I will be going in a reverse order because this is the most important. So if any slides get skipped, the important part would have been dealt with. Energy devices are of three kinds, which we use in a laparoscopic surgery: cautery, harmonic, and ligashore. I will be limiting myself more to cautery because today's session is primarily on laparoscopic cholecystectomy, and we are using this aspect more. In very specific cases, we use advanced energy devices. This is William Shakespeare, who's known for his adages. Rose by any other name would still smell as sweet. But in science, we need precision. What precision we need? Cautery, whether it can be called cautery or not, cautery is a misnomer. It's not the right term for what we use. The three terms are there: cautery, diathermy, electrosurgical unit. We are limiting ourselves to the correct terminology, and what we use is the electrosurgical unit, short term ESU. So let's be very clear from here on. We should not be using the word cautery. We should be using electrosurgical unit or ESU. Now, electrical surgical unit is a very dangerous weapon. And the more you sweat in peace, the less you will bleed in war. And any surgery is wartime. Surgical education is basically consisting of two things which are mutually independent: to learn to walk the right path and absolutely avoid the wrong path. Knowing one does not automatically entitle you to the knowledge of the other. They are two independent things, and we have to ensure that we walk both these things side by side. So besides knowing what to do with the ESU, we ought to refrain from certain things, doing certain things with it. And that's how we are going to use, we are going to avoid disasters. So what exactly are these things which are not to be done? It will be important to know these terms: direct application of the electrode, direct coupling, indirect coupling, insulation failure, capacitive coupling. I'll not confuse you. I'll take you through quick graphic explanation after giving you a brief theory. Now, what is direct application? Direct application is the direct placement of the active surgical electrosurgical electrode over an organ, which may be an organ of your intention, when errors happen, the active electrode may be from bad technique. It may have touched an organ which was not intended to be touched. This happens with premature activation of the active electrode while insertion, which is not to be done. Accidental overshoot, undershoot, slippage of the electrode from the intended point of application, which happens when you are in a hurry, when you are stressed out, when we are not stable, or there is a little chaos. Misidentification of a structure in which you think a structure is something, and then you apply the energy over it, but it's something else. Misjudgment frequently happens in laparoscopic cholecystectomy, or respiratory movements. In the field, we do a lot of people are doing lap chole under spinal anesthesia, and respiratory movements are a real problem during spinal anesthesia. During GA, we can handle them. If we are doing a cautery, we can request the anesthetist to just give a pause of apnea, and that can help us in not applying it to a wrong place. Working upon a mobile organ like an ovarian cyst, obviously in tense distended gallbladders also this may be relevant. When the organ slips and keeps moving, then at a particular point of application of energy, it might slip when the organ slips. Momentary lapse or diversion of concentration of the surgeon, very important. You got a mobile call or somebody is shouting from giving you a message, and you are doing the cautery. That's not you're doing the electrosurgical unit application. That's exactly not the way the thing has to be done. It has to be done with full concentration without any diversion, using the active electrode for retraction. So many times we are in a hurry, we coagulate, and then with the same electrode, we do a little bit of retraction. That's not to be done, because inadvertently it can be activated. So direct activation was the direct the current application to an unintended organ. Next is insulation failure. What is insulation failure? We all know that all elective electrodes are covered with a protective insulation sheath. And if you see any kind of laparoscopic surgery instrument which is electrode based, which can be connected to cautery, there's a sheath on this part of the instrument, and only the bare is the distal area, which is the working area, or which is to be in touch with the area of dissection. Now you can see that the only part of the entire instrument that is visible to us is just about 25%. There are 4 parts, 1, 2, 3, and 4. I'll come to that in a while. Only about 1/4 of it is visible to us. And if there is a break in the sheath, any kind of viscera which is coming in near contact, direct contact, or even a little bit distant, this can get a burn. So this is what happens from insulation failure. And as I said, the zones of the instrument, very important to know the instruments: zone 1, 2, and 3, and 4. We intend to give current only to the zone 1, but inadvertently during surgery, or when the instruments are not properly maintained or not properly chosen, I'll come to that in a while, the unintended paths can, the current can dissipate from any of these 3 areas, and that's where we get into trouble. So zone 1, 2, 3, and 4, only this part is to be active, but this at times fails. And when this becomes, the current leaks from here, it has been seen that in 18% of cases of disasters, the current had actually leaked from zone 2 of the instrument, which is not in the vision of the surgeon because it's outside of the monitor. And 18% of injuries, it is responsible for 18% of leaks. This area generally has a very small tip. So in cholecystectomy, generally we are very precise, so nothing happens. But this can be responsible for biliovascular injury if in case the anatomy is very tight there, and there's a lot of adhesions, and you're doing it without any identification, this can lead to below-vascular injury. This area, zone 3, the most interesting phenomenon is capacitive coupling. Any current leaking from this area can lead to capacitive coupling and major injury to the viscera. That's I'll come to a little while. Any leakage from zone 4 can give the operating surgeon or the assistant a major current shock, So this also is a very dangerous area. Any cord leak from here, if the cord is there, there's an insulation failure or loose wires are there, the current is, you can get the operating surgeon can get a direct shock from here. So this is what the instrumentation is. Coming to the next phenomenon, which is direct coupling. How does damage happen by direct coupling? Direct coupling is when an active electrode is touching a metallic part. Here the laparoscope is there, and a viscera comes in contact with this metallic instrument. This may be a laparoscope or a working instrument which is metallic, and a viscera or an organ comes in contact, which is again outside. We are focusing in this area, so this is outside of the view of the surgeon, and you won't even know that an injury has happened. So please keep in your mind the plastic part. I will refer to this in a little while, why this is important to our discussion. So this is what is called direct coupling. The next phenomenon is indirect coupling. Again, a very, very dangerous phenomenon at play during a laparoscopic cholecystectomy. What is it? Due to crowding of instruments during laparoscopic surgery, many times a metallic instrument can come in close confines of an active electrode without even touching it. That's why I said current jumps. So the current will within this distance is should be more than 2 centimeters. Always try not to get any metallic instrument in the vicinity of an active electrode. It should be more than 2 centimeters away, because as you may move near, the chances of a current jumping and conducting it to a distant organ, and this too without contact, this can happen. How it can happen, I'll tell you why. This area is grounded. You see the electrosurgical unit, the path is from the generator to the via the active electrode to the organ, via the patient, and via the earthing pad to the patient, back to the generator. So if the current jumps from this place to this place, this area is earthed, because it's with the patient. There's a short route of the current. So remember always that the current always takes the shortest route. So it jumps first from here to here, and then from this metallic organ to the metallic instrument to this place, and you will not even know that you injured. So this was indirect coupling. The next mechanism, then the most interesting and the most dangerous mechanism of tissue injury during laparoscopic cholecystectomy or any other laparoscopic surgery, is capacitive coupling. Capacitive coupling is that, as I said, when assembled, that thing, the complete assembly forms a capacitor. Now, this is the capacitor. This is the active electrode. This is the insulation sheath. This is the outer metal cannula, and this is the trocar, which may be metal or plastic. Now, let's see if it's plastic. Now, I'm coming to the plastic. I told you to remember why I'll be coming back to it. Let's see, this is plastic. Now, this capacitor accumulates current by inherent tendency of physics. Okay. So what happens is, there is current buildup in this area between the plastic and the active electrode with the intervening sheath, which is insulating sheath. This happens every time. Now, with a poor conductor here, this current is not going to be dissipated because this is not in contact with the skin. This plastic is not in contact with the skin. So this current is not dissipated, and it will take a shortest path with the viscera which is coming in contact, which is grounded. So this is going to cause an injury here. Vis-a-vis, if this is a metallic trocar, now what happens if the current buildup will be there? This capacitive current will definitely be there, but this is dissipated through the skin, and this danger really is less when metallic trocars are used. So in my concluding slide, I'll come to what is a preference of trocars. Here you see Let me get it to the other side. Here you see again, now this is the area of interest. Everything is fine. The surgeon, this part is under vision. The surgeon is proceeding very comfortably, but he's not knowing that the viscera is in touch with the metal hair. And there are some trocars which for fixation to the skin have a plastic sleeve. Very, very dangerous situation, because again, besides being a metal trocar, the dissipation part with the skin and the subcutaneous tissue is insulated. So again, there is buildup of current here, and an injury can happen to any viscera or organ here. This is capacitive coupling, most important and dangerous phenomenon, which the surgeon will not even come to know what happened.
Only 2-3 more minutes.
I'll have to really skip. Ergonomics, again, ergonomics is very important because we are discussing ports and instruments. Now, there are 3 angles. Ergonomics are very important because of the comfort. For the surgeon, the surgical fatigue is less, and more important, the ease of dissection and the display of structures and anatomy is much better if we honor the principles of ergonomics. Now, 3 angles are there: manipulation angle, azimuth angle, and elevation angle. We must take care of, in the triangulation process of placement of ports, we must take care of these 3 things. And the optimal manipulation angle, that is between the 2 working ports, working instrument, should be around 60. The azimuth angle is the angle between the laparoscope and the working instrument, which should be 30 on either side. Ideally, it should be equal. Elevation angle is the angle of between the working instrument and the plane of the operating organ, which we are operating, which ideally should be 60 degrees. The other thing is the optical axis. I will skip that since I have an important slide to show you. I'll have to skip a few slides. Now, this is very important. The electrosurgical unit, we have 2 modes, cut and coagulate. There is little difference between both of them, and you need to understand that the cut is low voltage, high current, and the coagulate is high voltage, low current. The temperatures are very high reached in the coagulation mode. So we always prefer a cut or a blend mode. Very important that the energy setting of the electrosurgical unit generator should be around 50 to 80 watts in the cut mode and 30 to 50 watts in the coagulation mode for it to function optimally without causing any damage. So anytime we generally prefer cut or blend rather than coagulate. Coagulate, if at all we need, very, very brief application. I'll come to the concluding slide. Prevention of electrosurgical unit mishaps, caveats. Inspect insulation carefully. Use the lowest possible power setting. Use a low voltage waveform. Use brief intermittent activation instead of just standing on the foot pedal. Hemorrhage or hemostasis is a skill, and cautery is not the answer for that. Cautery means ESU. Do not activate in open circuit. Open circuit means when the active electrode is outside of the body. Do not activate because the long circuit is there and stray currents are definitely going to damage somewhere the patient. Do not activate in close proximity or direct contact with another instrument. As I said, 2 centimeter is the distance. Prefer all metal cannulas or trocars over hybrid or plastic ones. Very important. We have certain advances in techniques, and these are tissue response generators and active electrode monitoring systems. They are the systems which sense a leakage of current from the electrosurgical unit, and they'll give you a warning that there's a leakage. So stop and check your instruments. Thank you so much, guys. I have absolutely no idea what kind of faith this has on his weapon. So it's very important not to have unrealistic expectations from your weapons. At the same time, don't land up doing harm from the use rather than good, which is intended, our aim. Thank you all for this, for allowing me to present this very important yet ignored topic for laparoscopic surgeons. Thank you.
Dr. Shalu, please.
Sir. Thank you, sir, for a nice presentation. You cover electrosurgical unit very well. And sir, as you told, when we are doing the safe and the judicious use of the electrosurgical units should be there. Otherwise, the chance of the injury to duodenum and the CVTs are more. And one thing is very important. Usually, whenever there is bleeding, do not use blindly electrocautery there. It is the most common cause of the CVT injury. So use properly, and port placement is very important. In the many time we saw there is a large liver. So we may go for the another port even on the left hypochondrium. So if do you need another port, no problem. You put another port, but do not do any injury to the structures.
Very true. I concur with each and every point what you've made. There's absolutely no debate on that.
Since there are no questions in the chat, maybe I can request other faculty, Dr. Sadiq, Ajay, Dr. TD, to make any comments.
Sir, very good evening, and thanks Dr. Kamaljeet for a lucid presentation. I want to add two important points. One is that duration of the contact. So if you go by the physics of the electrosurgical units, apart from the sitting, if you are having a more contact, means it will be the temperature generated will be much more, and injury can be more than what is expected. That's why you go in a purge, small purge, and then only do the this thing. Setting is very important, and all of us should know the tip temperature of the cautery, which depends on the setting as well as the duration of the contact. Second is the one more important point which we always think that we are always seeing in magnification. So at least twice magnification is there in laparoscopy in comparison to the open. So if you are putting your point of the contact, you are thinking that it is 1 centimeter away, but because you are seeing in a magnification, it might be only 0.5.
Yeah.
So I think these two important issues are also important when we are talking about all these things. Thank you.
Ajay has made a comment. Ajay, if you are there, would you like to elaborate on that? Dr. Ajay Sharma?
Yes, sir. I think when we are using a cautery, using a cautery in a bipolar mode will decrease the current spread. And second thing, similarly, if you're using it in a spray mode, the cautery may be helpful because then it doesn't cause a deep burn to the adjoining structure. So sometimes these two things may be helpful. In between, there was a lot of points people have raised that cautery should not be used it should be used in a cutting mode. I think I slightly differ from that because often in cutting mode, when you're using a cautery, it may cause a bleed, and in an attempt to control that bleed, you may overburn the tissues. So that is my.
For hemostasis control, I would never suggest a cutting mode. It's a blend mode, which is blend category 3, where there is nearly 50-50 cut, 50 coagulate. Probably that is the best mode, Ajay. You made a very right point. Cut cannot be used for hemostasis achievement. Actual coagulation, even spray is less damaging, but it's much more than the damage which is caused by a blend.
Kamalji, there's a question from Jayant in the chat.
Sir, I'll take the chat questions. Just a moment.
So he says, is it safe to take down the cystic artery with bipolar cautery or harmonic rather than conventional clipping and dividing?
As far as the harmonic is concerned, yes, definitely. I have no experience of using a bipolar, but I agree. People have been using bipolar for cystic artery. But one thing is sure, monopolar not to be used for cystic artery. Yes, harmonic and bipolar can be used. I think there's no harm in that.
Dr. Sadiq, any concluding comments?
Sir, can I ask one question?
Yes, Dr. Shalu, please go ahead, please.
Sir, I want to ask one question. Usually we are doing cholecystectomy in the second trimester if the patient come with the symptomatic gallstones. So there any difference in the pose position from the conventional port position?
Are you asking me, ma'am?
Yeah,
Yes,
Kamalji,
sir.
please take.
Yes, sir.
Yes, obviously, as we have to, the port placement, as I said, is triangulation method, the ideal one. But many times we have to modify the port position depending on the, as hepatomegaly might be there, or there's a large distended gallbladder is there, a big spleen might be there, or any other organomegaly, as in gravid uterus may be there. You obviously have to modify your port placement, and their ideal triangulation will not be achieved. You see, even in appendectomy, we are not doing an ideal triangulation placement of ports. That phenomenon is called sectorization of ports. It's a very difficult view. I didn't have time, didn't want to touch that. it's a difficult view when you are sectoring the laparoscope or vis-a-vis when you are triangulating it. So that is, I would suggest, yes, but that's an advanced surgery. I would not advise novices to take it because it's going to demand more skill and expertise in handling. Definitely modified port positions in pregnancy. There's no doubt on that.
Thank you, sir.
Kawaljit, one more question from Nabeen. What are your views about use of ligashore for cystic artery as compared to harmonic?
Obviously, it can be used because why? But why use it? I mean, the question is, see, I'll tell you what. Advanced energy sources are very expensive, and in most hospitals, they will levy an additional cost to the patient. It's not, it's in the OT and you use it. So, but why use all these things when you have a cautery and you can use it, electrosurgical unit is there, and at the most, you can use it on a bipolar mode. Why go in for ligashore? Of course, it can be used. It can be used for vessels up to 7 millimeter cystic arteries, 1 or 1.5, or maximum, not even more than 2 millimeters. It can be used, but I would not suggest wasting resources like this.
I think we'll move on.
Sir, can I take this question?
Yes, Ajay.
Yeah, sure, Ajay.
Just want to emphasize, very often the surgeons, what they do is they will put a clip onto the cystic artery, and then they will use a cautery also. I think that is a very wrong method to use because the clip gets burned and there's a burn into the cystic artery beyond the clip. So it will start bleeding. So always take precaution that once you have clip, don't use cautery.
Totally agree with you. Totally. And people are doing one more thing also. They use clips on the the CBD side of the cystic duct, and on the other side of the the gallbladder side they'll cut with a cautery. Again, the same logic. No, that's not to be done. The clips will fall off. Delayed necrosis will happen. They'll fall off.
Okay. Thank you, Kamalji. Thank you, Dr. Shalu, for accepting our invitation.
Thank you, sir.
Thank you, sir.